Hello, quick video on quadratics and different ways of solving them. Well, this is a quadratic equation. It's got a value of x squared in it, so it's no longer an easy linear one for us. We usually see these in problems with areas or speed, that sort of thing, where we've got a bit of shape in it. And everybody will probably start off with factorizing. I will try and break this expression into two factors, and as a result we can see here that x equals 1, x equals 3 would give us solutions, but this only works if we've got integers. So if we haven't got integers, we've got other methods of estimating. We could use a graph to do it, or we could do a trial and improvement method using a little table of values here. If we want to be more accurate, there's a quadratic formula, or another way of looking at that is completing the square. So let's have a quick run through and see how these work. Okay, our first one is factorizing. Find the factors of this expression here. So this relies on the fact that what we're going to do is break the x's into two different brackets, and then we're going to use that to solve our problem. And it relies on the fact that if we knew one of these numbers was a and one of these numbers was b, then our units will be a times b. So in this case, our a times b must equal 3. And we then look for integer pairs that will make that up. So in this case, we could have a equals 1 and b equals 3, that when we multiply them together, we're going to get 3, aren't we? But we've also got another thing we've got to match here, in that with our multiplying out our brackets here, our x value coefficient here, it's going to be a plus b. That's got to equal -4. So we have to check what our a plus b is going to add up to. So 1 plus 3 is going to give us 4, but we're looking for -4. So that doesn't work for us, does it? This is a bit of trial and improvement really here. And so what the others we could try? Well, in this case we could try -1 and -3, and if we multiply those two together we're going to get +3, aren't we? But if we add them together we're going to get -4, and that's what we're looking for. So we can see therefore that x squared minus 4x plus 3 can be rewritten as in factorized form as x minus 3 and times x minus 1. Sorry, that way around. And we want that to equal 0. Well, the two numbers multiplied together are going to equal 0 if one of them, the two numbers, is 0. So the first one could be 0, so it could be 0 times 5, say. Or the second one could be 0, in which case it could be like 6 times 0. And they're both of those would end up as 0, wouldn't they, as multiplications? So if the first bracket, x minus 1, is going to be 0, then x has got to be 1. And if x minus 3, the second bracket, is going to be 0, then x has got to equal 3. So that's all great, and it's really quick, isn't it, if we've got looking for an integer solution. But they may not be integer solutions. And if I change just a little the expression we were looking at earlier, which had a 3 at the end, and I put just a 2 in place of that, I've no longer, if you carry on the method above, you won't find any integer factors. So what we can do is estimate it by graphing it. So if we draw a graph of, there's our expression, and we make that equal to y, we can work out all the points for particular values of x, and we can graph them. And here we would end up with our blue line here. There's our blue line curve, rather, and it goes very high on either end here, we can see, and it comes down to a minimum here at x equals 2. But we can also see where it crosses the y-axis, x-axis, and that's the point at which y equals 0. Yeah, so here we have 2 points where it crosses, where it matches our requirement that that whole expression's got to equal 0. There we go. So here we could quickly see roughly off the screen that one of them is around 0.6 and the other one is at around 3.4. So that's a way to do it using a graph, and that gives us an approximation, doesn't it? Another way of getting an approximation is to use the same expression but make a little table of values. So let's have a whiz through this. So what I'm going to do is put in some values of x and do a bit of trial and improvement. So if I start off with x equals 0, I can see that that expression is going to be 2, but we're looking for it to be 0, so that's too high, isn't it? So let's try another number. Let's put 1 in. If I put 1 in, then this expression on, that we're looking for is going to be -1, so that's too low. But what's useful about that is we know the answer somewhere between the two, isn't it? If one's above and one's below, then we know it's somewhere in between. So let's try halfway, and if we try halfway at 0.5, our expression value is 0.25, so that's plus. So we now know the answer somewhere between 0.5 and 1. So let's go halfway again, and if we put 0.7 in, we get 0.31 out, which is negative. So we now know the answer is somewhere between 0.5 and 0.7. So we'll try 0.6. 0.6 will give us a y value of 0.04 minus, that is, so that's negative. So we now know that the answer is somewhere between 0.5 and 0.6 with the sign change, and therefore we're going to try 0.55, which gives us a positive value of 0.10. So we now know the answer is between 0.55 and 0.6. So let's go halfway again, and we'll do 0.58. And now we're getting really close, aren't we? Because our value is only 0.02, and we're looking for 0.00, aren't we? So that's slightly above. And we've already worked out that 0.6 is slightly below with these two numbers here. So let's go in between again. And if we try 0.59, we get the answer minus value for our expression of minus 0.0. 1, don't we? Which is the closest of any one we've got. And if we were only interested in finding our answer to 2 decimal places here, well, that's the closest, isn't it? That's the closest to our answer at 0.01, 5/8 at 0.02, and 0.6 is at 0.04 here. So we now know that if our accuracy we're looking for is 2 decimal places, our answer is x equals 0.59. Now we could carry out exactly the same activity starting with x equals 3, and we could then look at x equals 4, and if we did that and carried on narrowing and narrowing, we come up with our other answer, which is x equals 3.41 at 2 decimal places. But that's only an approximation, but it was pretty quick to do, wasn't it? So let's now try getting a more accurate solution using our quadratic formula. So here's our expression again, and what we're going to do is use this formula here, which you have to memorize for GCSE these days. And where we're going to get these A, B's and C's from? Well, they come from our this standard format of our quadratic, and these are the coefficients of the square, the x value and the units, and we're going to match them up. So here in the first one, a's got to equal 1 because that's 1 times x squared, isn't it? B is going to equal -4, and c is going to equal 2, so we write those out there, and then we substitute them in. So here where we had our minus b, there's our minus, and there's our b at -4, there it goes again. And we look at our a values to drop in, the 4ac, and underneath divide by 2a, and then looking at our c value, that's in our 4ac term, there's our 2. And if we simplify this out a bit, we end up with +4 and plus or minus, I should have said, we've got this plus or minus, I'll come back to in a sec, and what's in the bracket there, which is 4 squared minus 8, is going to give us 8. So there's a square root of 8. And with a bit of simplification and cancelling some stuff out, we're going to see that we've got a +2 plus or minus the square root of 2. So here we've got 2 answers, haven't we? One's with a plus and one's with a minus. So let's work those out. So one of them is going to be our +2 plus the square root of 2. One's going to be +2 minus the square root of 2. And if we put those in and turn it into decimals, we end up with 3.414 and 0.586, which are more accurate than the solutions we had from our estimates from the last 2 methods. So There's another way. People mess up the calculations there. They put the numbers in the wrong place, etc. So there's one other way of doing what we've just done with the formula, and this is called completing the square. Well, it relies on the fact that we can try and replace this bit here, the x squared minus 4x, with a term that looks more like something with a number squared, which in this case is going to be 2. And the reason for that is if we expand x minus 2, we would end up with, that's going to be x squared and minus 4x plus 4, isn't it? Okay, so this is the bit that we're looking for. And we can see quickly that if we were looking for that number, the number inside this bracket, well, what we've basically got is our coefficient here divided by 2, haven't we? So here's our x minus 2, and if we put that in there into the expression here, the thing about it is we've got an extra 4, haven't we? There it is. So this bit, to get that on its own without the extra 4, we have to take the 4 off. So what we've done is we can replace this part of it in our expression with that, and there's our original 2 from the top. And if we reorganize this so that we've only got this, we want this x minus 2 brackets squared on one side, we want all our numbers on the other, then we've got a minus 2 plus 2 there. If it was on the left hand side, it's at minus 2, isn't it? But if we add it to both sides of the equation, we end up with plus 2. So if we're comfortable with that, we've reorganized our equation from above. And what we're going to do with this, well, we don't want it to be squared, we want it to be the ordinary, so we're going to square root it. So the left hand side is going to be x minus 2, and the right hand side we have the square root of 2. But also we're going to have the answers, we can either have plus or minus that, because plus the square root of 2 times the square root of 2 is 2, and minus the square root of 2 times minus the square root of 2 is also 2, isn't it? Because minus 3 times 3 is 9, minus 4 times minus 4 is 16. They're always positive. 2 minuses multiplied together make a positive. And so once again we've got two solutions here, haven't we? We've got x plus 2 plus or minus 2 square root of 2, which is what we saw earlier. That brings us back to our 3.14 and our 0.586. But this expression is quite interesting, these two solutions here, the way it's written, because actually if we go back to our graph, which we did earlier, so we'll look at it here, what we've actually got is that we've seen that we've got a line of symmetry down the middle here, which is the x equals 2. So there's our 2 part. And then what we've got going either way, if we were at this intercept point here, the crossing point, that's minus the square root of 2, and that's plus the square root of 2. So it does have graphical meaning, what we've just done, doesn't it? There's our two answers. It's 2 plus or minus the square root of 2. So there we are. That's how it works. Here are 4 methods of working. Firstly, try and factorize it. If you can't find integer values to go into your factors, then you can estimate it using a graph and find these intercepts. Or you can estimate it through trial and improvement, and looking at the sign changes and find the x and y values for that. If you want a more accurate solution, you can use the quadratic formula. And you can also, if you don't like that because you keep messing it up, try complete the square as this method here. Find out what that square's got to have to be, and hey presto, you're home as well. There we are. I hope that's of use, and very best of luck.